Yeah, I've started on this.
Upcoming. Let's see. Yeah, live now.
Yeah.
Shall I mention we are live now?
Is there any way for you to stop the recording on Zoom?
No, no, no.
Varun has entered. Okay, so we'll edit that later on.
Yeah.
Hi, Varun. Good morning.
Good morning, Varun sir.
Good morning. Good morning. Am I audible?
Good morning.
Yes.
Yeah,
Loud
good
and
morning.
clear.
It's a little bit tricky, I guess. So, Varun, here's what we will do. We'll start off with the introductions. Nitin will start with introduction to AMSAT India, his introduction, a brief one, your introduction, and then we'll start with how do you like to do? You'll like to start with the presentation directly, or we'll go into the question answer mode?
Anything is fine. You take a call.
No. If you have a presentation, then maybe you can complete the presentation. So what we want to do is here we are going to be only four of us: Nitin, you, Devendra, and me. Rest of the people we are streaming this on YouTube so that nobody will be able to intervene in between. Okay. Uh, what we can do is we can go ahead with your presentation. Once your presentation is done, if there are any other points which are pending out of those questions, we can cover them. And then if there is somebody on the YouTube chat, somebody has asked some question which we have not covered, we can take that question later on. Is that okay?
All right. All right.
Okay, fine.
Hi, Varun. Good morning.
Good morning, Nitin.
How are you?
I'm fine. Hope you're doing well.
Yeah. So, Varun, I just forgot to add in your slide about AMSAT India. So,
Yeah.
I have two slides on that. So, I
Yeah.
will share it from my end.
Okay, no pressures. Absolutely fine. I am game
Because
for
I
everything.
forgot to add it in your tech actually
Uh,
yesterday.
I know I'm fine. I'm game for everything.
Okay. Ajay, what does the PHARC stand? Pune Amateur Radio Club, or you're on mute, Ajay?
Sorry. It's our club repeater call sign. VU2PHA is our club repeater call sign, and the name is VU2PHQ. So the name of the uh, PHARC is what we call Pune Hamsan Amateur Radio Club, and VU2PHA is a repeater call sign.
Oh, okay. No. No. Yeah.
Good morning, all those who have joined. We'll start sharp at 11. We still have some 7 minutes. We'll wait for some time by the time everybody joins, and we'll start sharp at 1100 hours IST.
Hi, Ajay. Just letting you know the share has been disabled. Sharing screen has been disabled.
Hey, unmute.
You should be able to just try again.
No. Host disabled attendee screen sharing.
Yeah. Yeah. One second. I just.
Yeah, I am able to share now.
Right.
Try, Varun.
Yep.
Yeah, okay.
Yeah.
Make you all a co-host so that in case there's an issue, this thing will continue. Everybody is a co-host now, so should not be a problem. We started the recording.
Okay.
Good morning, all. I think we can start. It is 11. So, Devendra, you are ready. Nitin and Varun, can we start?
Yeah, sure.
Yeah.
Okay, we can.
Okay, yeah. Thanks. First and foremost, I'd like to welcome both of you, Nitin and Varun. Thanks for joining this session. Thank you so much. And I'd also like to welcome all the people who are there watching this video live on YouTube. Thanks for joining this session live. What we should do is we'll start with the introduction. So I would request Nitin, if you could share a brief introduction about AMSAT India, what it is all about, what it does, and your personal introduction, and then we'll follow it by Varun. Over to you, Nitin.
Yeah, sure. Thank you very much, Ajay, and good morning, everyone. First of all, thanks to the Pune Amateur Radio Club for inviting us to this session. We'll do our best to kindle that interest about amateur radio satellite operations. I have Varun also over here, who is the main presenter. So before I start, I would like to give a brief introduction about AMSAT India and myself. So my name is Nitin, Nitin. My call sign is VU2 Juliet Echo Kilo. My previous call sign was VU3 Tango Yankee Golf. And I'm based out of Bangalore. I'm IT professional. Got my amateur radio license in 1991 and have been active on the amateur radio bands since then. So let me share my screen. Let me know once you guys can see. So basically, I would like to introduce three organizations over here because this is something that you will come across. Is my sharing visible, Ajay?
Yeah.
Okay.
Yeah,
So,
if you could
yes.
just presentation.
Okay. How is it now?
It's better, sir.
Okay.
It's
Okay.
visible.
Right. So I would like to
Sorry,
introduce.
Nitin, Nitin, you need to swap the screen from the display setting on top.
Oh, yeah.
Just
Yeah.
do a swap the screen so that we'll be able to see the entire presentation. Sorry.
1 second. Yeah. It's
Yeah.
okay?
Thanks.
Okay. So I would like to introduce three organizations over here. The first one is AMSAT India, to which myself and Varun belong to. Again, it's an organization for the Indian amateur radio satellite programs. And I think you're all aware that every country has got its own organization. AMSAT NA in the US, AMSAT UK, AMSAT France, JAMSAT in Japan. So similarly, AMSAT India is a organization based out of India for the Indian amateur radio satellite program. Then you will also come across another organization called as ARIS, that is the amateur radio on the International Space Station. This is one of the favorite satellites, you can say, where you can work through the International Space Station. And I also understand that the students have some questions, will be having some questions regarding their satellite program and satellite frequency coordination. So this is done by an organization called as IARU, right? So these are the three entities over here which I wanted to introduce. Again, the goal of AMSAT India is to connecting classrooms to space. So what is AMSAT India? As I mentioned, an organization for the Indian amateur radio satellite program and promotion of amateur radio activity in space from India. And we also operate through a partnership between academia, space startups, and the National Space Organization. And as I mentioned earlier, ARIS stands for the Amateur Radio on the International Space Station. Again, it's a global program that lets students talk directly to astronauts on board the ISS using amateur radio. And it also operates through a partnership between ARRL, AMSAT space agencies like NASA, ESA, JAXA, etc., and amateur radio organizations. So on the ARIS program, I think all of you must have already heard about our Indian astronaut, Shubhanshu Shukla, who was on the space station. And through the ARIS program, we were able to have him to talk to school children in India. And what is IARU? Again, it's a body that does the frequency coordination for spacecraft using the amateur radio frequencies. And AMSAT India, again, some history and background, was formed as an informal working group in 2000. And later, it was as an organization incorporated as a non-government, non-profit voluntary organization. And ARIS started in 2000, and the first contact was in 2001. Earlier, it was built on the shuttle radio experiments called as SAREX. And the aim was to inspire students to pursue STEM education. And IARU was started in the 1990s, and it has played a key role in frequency coordination and overseeing the use of radio frequencies for amateur satellites. And these are the office bearers for AMSAT India. The president is VU2 RMS, Ramesh Ramsubbu. The post of vice president is to be decided. I'm the secretary. I had to update my call sign there. That's my old call sign. We have Venkatesh, VU3 ICC as the treasurer. We have an open position for the director educational relations and the technical director. And we have committee members, Ganeshan, VU3 GEK. I think you must have seen a lot of his projects. Dr. Ravindranath, VU2 RVJ, Somshekhar, VU2 HCJ, Balaji, Somshekhar, VU3 JBA, and Air Commodore V. Subramanian, VU2 UV. And we also have a director for regional coordination, that is Somshekhar, VU3 JBA. And we have regional coordinators for North, it is Kaustav, VU2 UU. And for West, it is Rajesh Wagadia, VU2 Echo X-ray Papa, and I also manage the public relations. So that's about the organization. Varun, you can go ahead with your presentation.
Thank you, Nitin.
Varun, if you could just start with your introduction first, that'll be great.
Yeah, thanks you, Ajay. I am Varun. My call sign is VU3 India Papa Uniform. I have been a satellite enthusiast for quite some time, maybe 5 years or so. Basically an academician working for an organization called Ramaiah University of Applied Sciences, where I do research on defense, basically on aircrafts, starting from the Russian origin to the Indian origin Tejas. Also build radars for the Indian defense. So that is my brief introduction. We'll just dive into the presentations right now. Is the slide visible?
No, not yet.
Yeah, I'm sorry.
Not yet.
No.
Yeah. So a very good morning to one and all. I am Varun. My call sign is Victor Uniform 3 India Papa Uniform. This is a presentation for
Varun, your sharing is not visible. I don't know whether it's only for me or Ajay, Devendra.
No, it's not. No, it's not. It's not visible. Varun, you'll need to share again.
Right now?
Yeah. Now
Yeah.
you can see.
Yeah, a very good morning. I am Varun. My call sign is Victor Uniform 3 India Papa Uniform. This presentation, this technical presentation for about 45-50 minutes is about satellite operation on amateur satellite operation, especially for hams. So just before presenting, these are some of the, I will be talking about some of the applications. It is not limited to these, there are other things also. And the slides are essentially for the basic operations for a person to start with satellite operations, especially voice.
Varun, just a quick one. We are able to see your screen.
Yeah.
We are not able to see the slides. So
just give me a second. Right now?
yeah.
Yep.
It's visible now. Just put it in the presentation mode.
It's in presentation mode.
Perhaps your other screen or other window is being on Zoom.
Okay, fair enough. Just give me a second. Just give me a second.
Is it a PDF file, Varun?
No, it's a PPT. How about now?
Yet to come.
Yet to load.
No. Yeah, something is coming. Yeah, so we can see the slides, but it is still not in the slideshow mode.
I mean, full
Which
screen.
is okay. Let's continue.
I think let's go ahead. Yeah.
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 So the overview of today's presentation is some sort of what are the satellite operations, what are the satellite applications, and how do I decode data from the satellite, and then we take some few questions. The important terminologies for any satellite, what is an orbit?
Varun, your slides are not moving. You're still on the slide, the first slide. Do you want me to present?
Yeah, that would be great.
Okay, I'll do it. Hold on.
Nitin.
Yeah, screen is visible.
Okay.
You need to share. Nitin, you need to share. Yeah. Yeah, it's visible. We're good.
Yeah. The overview for this presentation is looking into the satellite operation. How do I operate on various satellites? What are the do's and don'ts? Some sort of what are the applications that I can run on a satellite? What I can look into? What are the other than voice? What other things I can look into? How do I decode the data from various satellites? And then we take some questions. So this is the overview of this presentation today. The next is Nitin, there are important terminologies. One is the orbit. That means the path the satellite travels around Earth is known as the orbit. Then the next one is the most important one is the Doppler, the shift in frequencies because of the relative velocity of the satellite is basically Doppler. This is necessary if you are tracking the satellite. And then some of the orbits, low Earth orbit, high Earth orbit, as well as geosynchronous orbit. So these are the three orbits. Low Earth orbits are basically the orbits which is from 400 kilometers to around 2000 kilometers. Most of the Oscar satellites or the amateur satellites are in this orbit. The high Earth orbit is basically an orbit which is a distance of around greater than 20,000 kilometers. And then you have the geosynchronous, where the satellite is always seeing a particular swath of the Earth, that is the particular area of the Earth, which is actually placed at 35,680 kilometers. So these are the three orbits. There are other orbits also, but this is the generalized orbit that we are looking into. Then there are two frequencies. One is the uplink frequency and the downlink frequency. The uplink is basically up. When I say up, it is basically from my ground station to the satellite. So the frequency that is used to transmit to the satellite is uplink. And then when I say downlink, it is from the satellite to the ground station or your receiver. So that is called as the downlink. Then the footprint is nothing but the swath or the area covered or the circular area the satellite is in line of sight. Then the two other things is apogee and perigee. The highest altitude and the lowest altitude is the apogee and perigee respectively. Then the inclination, the angle of the satellite where the equator is 0 is basically the inclination. So these are some of the terminologies that is necessary for any amateur satellite operator. So the next would be What is an amateur satellite? An amateur satellite is basically also known as an Oscar, or orbiting satellite carrying amateur radio. So you have a transponder which basically it's like a repeater. So it is basically you send a signal to in one frequency, that is uplink, and then it transmits in another, retransmits the same data in the other frequency, which is called as a downlink. It is basically playing like a ping pong of radio waves. So a LEO satellite is basically between 100 to 1,200 miles above the Earth, and most of these Oscar satellites are essentially in this distance. So there are operating modes depending on the frequency. One of the operating modes that have shown is UV mode, where U is basically the UHF frequency or the 70 centimeter band, and V is basically the 2 meter band or the VHF. So when I say UV, it essentially means my uplink is 70 centimeter band and my downlink is 2 meter band. It can be VU also, it can be other frequencies. For example, SX is there. There are other, you have one more in LS. There are other bands also, but most of the Oscar satellites will be UV, UU, or VU, etc., etc. There are other satellites that use common transmission modes. The modes are basically how do I connect to the satellite. Essentially single sideband mode. Then you have FM, CW, and data. So these are other modes, but it is not limiting to this. There are other modes also, but most of the voice essentially comes from these two modes, that is SSB and FM. CW is, we know, the continuous Morse code can also be transmitted, and data is when you look into the digital transmission. Digital transmission, it's a little high level, where the downlink and the uplink is basically either in BPSK or QPSK or QAM, 16 QAM modulation techniques, which is a digital technique, with some sort of correction techniques because it is not resilient to noise. So hence you have some sort of a Reed-Solomon or half-rate convolution decoder to decode the data. So these are some of the modes that a ham operator needs to be have a knowledge about, especially the SSBs, FM, and CW. So the next would be the satellite beacons. This is the basic general terminology, or what you call as a telemetry. A satellite which passes over a given area will always transmit the status information. That means to say it will essentially tell us what is the battery charge available. Is there any issue with if there is an altitude meter, it will share the altitude also. If there is the solar panels, what is the tilt, and other data. So these data is sent in the downlink as a telemetry. So this can be decoded by anybody having a radio, having a SDR, and some amount of knowledge on how to decode voice data, meaning how to use this radio waves, convert it into an audio, and then decoding using sound modem will be able to receive this. And he will be able to decode the data along with this information. And I'll show in the future slides. I'll also say how data can also be transmitted over this telemetry. One of the examples I'll show you. So these are not encrypted, should not be encrypted if it is in the amateur radio frequencies. And these are meant for monitoring by the ham operators worldwide. One example to give is one of the satellites that is dying right now, which is called as an Arctic sat. They are sending telemetry data every now and then and asking the amateur radio enthusiasts to give them the report on what is the status of the satellite. So that is one of the things that people are doing world around since past 3-4 days. So there is one example that I can give you with respect to the telemetry. Then there can be some special transmissions that can also be decoded. For example, it can give you it can give, let us say, Happy New Year data. It can give you what is the objective of the satellite doing, and then these data can also be, a text message can also be embedded into this into the telemetry packet. So, and also this is basically what they say is it is like a lighthouse. It essentially gives us in what is the orbit of the satellite and what is the status of the satellite. And this is essentially required for what is called as the station keeping of the satellite. So the station keeping is basically looking into the parameters, the orbital parameters of the satellite. This is given by the telemetry, and then they do a course correction if there are thrusters. There can be a Hall thruster or any other thruster to course correct the spacecraft. And in case of CubeSat, because the mission is only for 6 to 8 months, in some cases it is 3 years, small thrusters can be corrected now and then to correct their altitude. So that is basically the requirement of beacons and telemetry. There are multiple events that are happening with respect to this telemetry decoding all around the world. So that is where some who are really interested in some technical information about this telemetry can look into this further. The next one would be how do I what are the tracking and operating satellites? How do I do it? So for that, what do I need? This is basically where the fun part starts. These are certain parameters that any ham would have to spend a time in. One is the frequency. So this is the single most aspect or the most important aspect of anything that a ham operator would like to look into. So most of these Oscar satellites operate on VHF, UHF bands. You can actually use this directly from your shack. You will be able to communicate. Most often you will be using one band for other uplink and another band for downlink. So this is what you need to look into. Then for the tracking, this is not a stationary repeater like the regular network. So the satellite will always be moving. So the overhead pass that is there needs to be tracked. That is tracked by what is called as two-line element or what is called as TLE. This information is got from some mathematical calculations and other things. This TLE comes from when the satellite is launched. So and then it gets updated every now and then. Most of the satellites, some of the critical satellites, the TLE gets updated for every 4 hours. In some cases, every 8 hours. It is always prudent to update the TLE to have the good tracking of your satellite. Because pointing of the antenna towards the satellite becomes a very essential thing to get good QSOs. So that is one thing that we need to look into, and there are multiple softwares. We will touch upon this at a later stage, and what are the softwares that can be used. The next important thing is the antennas. These contacts can be made through multiple antennas. There are multiple options that are available. The basic antenna that anybody can use is basically a homebrew Yagi, which can work in either in UHF and VHF, or you can use an arrow antenna, which is a dual band arrow where we have both UHF and UHF. This can be used for tracking the sat. So basically, a handheld tracking can be done, and then you can. The other thing that most people might have to look into is the power. Unlike the terrestrial repeaters, you don't require much power for satellite contact. A small, let us say a 5-watt handheld is more than sufficient. And also, it is not prudent to saturate the satellite repeater with higher powers. So always look into that you use, let us say you pump just 5 watts of power. They're not pumping 30 watts or 20 watts. In some cases, the LNS gets saturated, and sometimes the repeater also gets burnt. So these are another issues that a ham operator has to look into. So the power needs to be not much. A little power is more than sufficient. So the next would be I would touch upon would be the types of satellite operation. So there are basically there are two, but I would put it into 3 categories. One is the FM satellites. These are basically like a simple repeater in sky. It is very good for beginners simply because a simple Yagi antenna, a 3-element Yagi, with a small handy can be sufficient to receive or transmit data to these FM satellites. The next would be the linear transponder, where these receive a range of frequencies in one band and retransmit them in another band. Basically, an SSB kind of is basically an SSB transmission. So that is what is the difference. You need maybe you need a sophisticated duplex transceiver or a rig to do this. That is the difference. The other is the International Space Station, which is actually having a amateur radio equipment on board. So this allows astronauts to make contacts with Earth and other hams around the world. So this is what Nitin was speaking about, where Group Captain Shukla was able to do this from the International Space Station to one of the ISTRAC ground station in Bangalore. So this is one of the application that can be done. The other advantage of ISS is basically when anybody wants to get into some satellite tracking, the best way is to listen to the International Space Station, simply because it is more active. Second, the power output, the power is too high, and then you will be able to get clear signals out of this. Always, most of the time, it will be 5.9 in most of the cases, because the power levels from the amateur radio equipment will be high. So it's a good starting point to start with into ISS, then FM satellites, and then linear transponder. This is my way of expressing, and it works out for me. But for others, it might be a different scenario. But this is what I would recommend. So the next would be, I would look into the frequency bands. So the satellites that are there, actually most of the satellites are a 1U or a 2U or a 3U satellites, CubeSats. And when I say 1U, it essentially means the satellite is of the size 10 centimeter by 10 centimeter by 10 centimeter. So that is the size of the satellite. And with this kind of a satellite, with some sort of a whip kind of a satellite, the antenna that comes out of the CubeSat, you do not have a large space to separate the receiving and transmitting antenna. So you do not have space. The reason why space is required is simply because there will be a coupling between the two antennas in two different bands. So what does this coupling do? The VSWR, or the return loss, the S11 of these two antennas gets detuned. So to avoid this, one way that terrestrial things they do is they space out both the UHF and VHF or other frequency antennas, but this is not possible. So what happens is they use the same antenna for both VHF and UHF, and that is one thing. The second thing is there are modes. There is something called as a mode A, which uses 10 meter and 2 meter bands. Mode B is 2 meter and 70 meter bands, and mode J is 70 centimeter and 2 meter bands. These are the modes in which the people will be able to, the uplink and the downlink. The first one is the uplink, the second one is the downlink. When I say 2 meter, 70 meter, the first 2 meter is the uplink and 70 meter is the downlink. But there are new satellite band designators that are paired now. For example, I've just given you a few things. One is VU. U is basically UHF. L is the L band frequencies that comes around 1.6, 1.7 gigahertz. Then you have an S band, which comes around 2.2 gigahertz. That is a 13 centimeter band. Then you have C band, which is 7.5 centimeters, and X band, which is 3 centimeter band. Then you have the K band, which is 1.5 centimeter, and then you have the Q band. So these are the new designators that are there, and you can have a permutation and combination of these bands. So I have worked with L and S bands, and I have also worked in X and C bands. That can be done. That depends on the satellite, that depends on the size, that depends on the link budget, whatnot. That becomes too technical. Let us not go there, but I'm just giving you a hint that it is not just VU. There are other bands also that you can work around. So these are the frequencies that anybody should look out. Especially a new ham operator. The thing that is more important is basically the VU, the 2 meter band and the 70 centimeter band, which falls under the the frequency regulations on the WPC in India. So that is the two bands that you can look into, the mode B and mode J to be exact. So the next I would touch upon what are the satellites that are available and those frequencies. I've just mentioned the few satellites that are available right now. These are the FM satellites. These I will not go much in detail. I will just leave it to you to look into those uplink and downlink frequencies with the CTSS. This can be configured on your handy or your rig, whichever rig that you have, and then you will be able, and with an Aggie antenna, we will be able to do some QSS on these satellites. Right now, some of the satellites that are active are listed. There are few more, but that depends on when they activate and when they stop the activation. That is put out on the AMSAT.uk website. You can also have it on. You can go and have a look at it. So this is the latest table that I got. This is updated on 27th May, last month. So there are other things that you can look into, but the reason why I put out is you can have a look at, you have the combination of both V and U and U and V. For example, the ISS uplink is 145 dot something, and then you have a downlink, it is at 137. So this is basically a VU. Similarly, AO91, if you look at AO91, it is basically the reverse. So the uplink is basically at 136, 135, and the downlink is at, the uplink is at 435 and the downlink is at 145. One thing that you have to look into is when you have the VHF frequency, the VHF frequency is same, meaning it's a constant frequency, whereas the UHF, if you see, it is basically varying. When you see the AOS to LOS, it essentially varies from, let us say, plus or minus 0.1 megahertz or 0.2 megahertz. This difference is basically the Doppler shift. We'll talk about Doppler shift in a while. So the next I would touch upon is the Doppler effect.
So Varun, just to add to this list of satellites, what you're sharing, these are the most easiest ones is the ISS crossband repeater. So the International Space Station has got a crossband repeater. I think all of you some of you must have played around with your radios crossband repeater. Similarly, the ISS has got a crossband repeater where it receives the signal on 145.990. It has got a CTCSS of 67 hertz, and the downlink is on 437.800. And as Varun mentioned, I think they are putting out almost about 20 watts from the ISS crossband repeater. It is basically a off-the-shelf Kenwood radio, base station D710, which is used on the ISS. And this is the most easiest satellite that you can work. And then, of course, we have SO50. SO50, basically, it's also called a Saudi sat. But here on the uplink, that is 145.850, you will have to give a 77 hertz tone to power on the transponder. And then subsequently, with your transmission, you have to put a 67 hertz tone for your signal to get through the SO50. And then for the IO86, called as LAPAN, this is in an equatorial orbit. And the advantage is that you will be able to get this satellite every 1 hour, 40 minutes. But the satellite team have published the schedule because it has got other payloads as well. It has got an APRS digipeater as well as a FM transponder. So there's a schedule that is being published when these payloads will be activated, whether the satellite is going to be active on the FM transponder or it is going to be active on the APRS. And similarly for the KWT satellite and TEVEL also, they have a schedule when the transponders will be turned on. And by the way, for the International Space Station, it is not just the crossband repeater. They also have a APRS digipeater on 435.800 or 436.800. They have a APRS digipeater as well, and also on 145.825. So there are various other satellites that are available. This is just a small list, and there are a lot of resources on the internet where you can actually see what is the status of each and every satellite which is being launched. Go ahead, Varun.
Yeah. The next would be the Doppler effect. So I am just giving a simple example of what would be the effect of Doppler. Let us say I have a handy that is connected to a Yagi, which is an uplink on the left-hand side, which is saying 145.800, which is my uplink. This is basically the UHF frequency in which I'm doing an uplink to the satellite, and that gets translated to 436.8 megahertz on the downlink on the right hand side. So you will be receiving, the other person on the other side would be receiving at 436.800. So this is true when the satellite is essentially stationary. That is not the case. The satellite is always moving. So once you see the satellite on the AOS, the frequency will be your 436.800 plus 20 plus 0.2 megahertz, and when it reaches the maximum inclination or the maximum elevation level, your downlink frequency would be 436.8, and as the satellite goes to the other side, essentially your downlink decreases or the downlink frequency goes down. So this is essentially shown in the bar that is shown where the pointer is, where the downlink frequency starts from 436.790 to 436.810. So these are the frequencies in which your radio needs to be tuned to. The other thing is also that needs to be looked into is the tuning is one part. The other thing is the most would be not a problem, but if you are rating on an SDR, the bandwidth also needs to be looked into. I'm just giving the idea of how to operate on a SDR also. On a handy, the bandwidth is fixed, but whereas in case of your if you are operating the satellites with an SDR for the downlink, or some people use SDRs for the uplink also. Then the bandwidth of operation is more critical. Where do you get this bandwidth information? As Nitin pointed out, there are multiple websites that gives out what is the kind of bandwidth that is required. For example, if it is CW, what should be the bandwidth? If it is 9600 baud rates, what is the bandwidth? That information is already given on multiple websites, so anybody can access those and then set those parameters according to each and every satellite. So that is what I wanted to talk about with respect to the Doppler. Most of the time I don't change or shift in the uplink frequencies, because the lower frequency is a little bit resilient to the frequency drift or the Doppler effect, but it is only at the higher frequencies, that is the 436 megahertz, meaning the UHF frequency, I need to bother about the Doppler effects. So with this, we will talk about something on the linear satellite next. What is this linear satellite called? Linear satellite is nothing called as a bent pipe transponder. When you say bent pipe, the one thing that comes to my mind is the traveling wave tube amplifiers, which are used in the bent configuration. These are nothing but amplifiers that basically amplify your signal and push it into other frequencies. So for example, it converts 20 kilohertz to 100 kilohertz of spectrum in one band to other. It allows the advantages, it allows many QSOs at the same time. It is basically narrow band modes, especially CW and SSB modes use these satellites. The linear satellites use this. Usually inverting, that means it converts, its convention is USB on the downlink and on LSB on the uplink. So you use LSB for the uplink frequencies and then you get the downlink on the USB. So there are multiple satellites in linear satellites also, like what you have, what is the list that we have shown. There are multiple more linear satellites. We can use either CW or SSB, but this one is most of the handies cannot be used for these linear satellite operations. That is one thing that needs to be looked into. And one more thing is, do not use FM in linear satellites. That is one more. Do not don't for a linear satellite. There are rigs available. There are handies available that can give us CW as SSB. So please use those. Yeah, you can receive these data or the voice from your linear satellites through SDR. So that is possible. But if you want to transmit, kindly look into those things. So just to look into, the next would be what are the applications. The applications are not limited to these. There are multiple more. At least I can at this point of time, I can see another 10 more. But the basic would be voice for QSOs on FM and linear. FM and linear means the satellites can be FM or linear. Then you can look into the telemetry. We can also APRS use the packet service as well as digipit through various satellites. You can use FT8, FT4, FT2 digital modes in some of the satellites. We can also transmit using CW. You can use the Morse code for transmission. Then one of the simplest thing that just to listen into is basically the SSTV. So slow scan television is also one of the applications that one can look into. So to look at to see most of the times on the right hand side, I've just shown an arrow which is basically meaning a VHF antenna. Yagi. This can be used. This kind of antenna can be used. This only for depiction. This can be used for either for transmission and reception. But the ultimate aim is to what I've shown on the left hand side, which is basically VHF UHF mounted on a G5500 rotator. This is from our Mattin VU2 JEK's station. The images from his station. This essentially gives us beyond line of sight communication is also possible with this kind of a setup, where you get at -5, -6 degrees, you'll be able to do some QSOs, where you will be able to reach regions which others cannot reach. So that is the ultimate game. So this one is save up so that you can build a station, something like that. So the next would be satellite operation. So satellite operation would be, you have a computer that is connected to a sound modem, 96. It can be a different baud rate. I'm just giving you an example, and that is connected to two different transponders or a single transponder, a 2-meter one and a 70-meter one. That is connected to your Yagi antenna. You can also have a preamplifier when you are receiving on the 70-meter band. So this is more than sufficient for the operation. So just to give you how does the satellite operation work, you have, let us say on the right hand side, I've shown that there is a caller A or a user A, which is having a call sign. Then you basically give out your call sign, complete call sign, and then it gets repeated to the other end, and then you can do the QSOs. This is basically the operation. Do's and don'ts, I'll come in a bit. But ultimately, what can you look into is a complete ground station will have a rotator. You can have a VHF, UHF. You can have a grid antenna. You can have a dish antenna. And you have some sort of an SDR server connected into a complete grid. And you can also have some online user using that grid. You can have data that can be put it into a cloud. You can use the data for big data analysis. All those things can be done. So ultimately, the large ground station would look something like this. But at start, you can use a small setup like a handy and an Yagi and start doing your QSOs. So the next I would look into is for how do I start the operating procedures on an FM satellite? So because that is the most thing that is a basic thing everybody has to start with. First and foremost is to listen before you transmit. So I'll first listen, don't transmit anything. First listen to the satellite. Somebody would be doing a QSO, so kindly wait for them, listen, realign the antenna for to improve the reception. That is the first thing that have to be done. Next is be brief. Do not beat around the bush, be brief. Many stations also exchange QTH first names, not necessary. Take turns, just wait, just take turns. You have, if you have already worked on some few stations, be polite, hand over the transponder to somebody else to do their QSS. So don't overwhelm everybody. Then a simple announcement saying that this is my call sign and listening, that is more than sufficient. Just wait, just wait for your turn. If QSO is in progress, wait until they finish, they are putting down your call, please wait. Don't tune up. Do not put, when I said do not, when I said don't tune up, do not say hello, hello. Do not say mic testing. Don't do all those things. Just wait. Just start with your call sign and listening. And finally use the minimum power necessary. Do not saturate the satellite. Do not saturate the LNA of your satellite. So that is what are the minimum procedures that has to be done. But there are some good practices that I'll get back to you in the next slide. So the good operating practices share the pass. First thing is FM satellites are just repeaters. Only one person may transmit. Only one person may transmit at a time. So do not monopolize the pass. Once you are done, share the pass. The other thing is if there is a QSO that is being done, please do not get into that bloodbath. Just wait, let other stations complete, then start with your whatever call sign. Minimize repeated QSOs. Refrain from calling the same station that you have already made a contact. Don't do that. Look out for rare stations, better stations, and stations that you have not got into contact. Don't call CQ. CQ satellite essentially means basically you are calling the satellite itself. Do not do that. Just say, give your complete call sign. That is, in my case, it is Victor Uniform 3, India Papa Uniform, and you can give your grid location. Mine is MK82SX. You can give your, or you can just say, you give the complete call sign and just say listening. That would be great. The other thing is use phonetics. That would be the great thing. Please use phonetics. That will enable all your QRMs will be effects will be reduced in that case. Meaning, I'm not saying reduce, but even in QRM cases, you will be going through it. Then rare portable stations takes priority. Give priority to portable stations and rare stations that you want to look into. Then work for new stations. Do not have contacts with the same old station that you have already worked with. So these are some good operating practices. That is with respect to this. Then from this slide on, these are some of the examples that I have got into where how do I build a simple ground station? I have taken one of the ground station which is there. This is a basically tiny GS ground station. This is from VU to LBW. This is one Lucky who is Lakshmanan who is doing this, who is having this ground station. So this ground station is very easy to work with. Doesn't need any any SDR, anything. Only an antenna as well as one of the LoRa modules is sufficient. The cost is low. It's a cost-effective solution. You will be able to receive packets. You will be transmit. If you have a call sign, you will be able to transmit some hello packet also. So this is one of the simplest ground station anybody can build to start with. And then you can also exchange, as I said, you can also exchange some hello packets. That is what it is. Then you have what is called as satellite CW. Satellites basically also transmit CW signals. You can also transmit CW data. Here I wanted to show how I can use an SDR to receive a CW signal from a satellite. I think Nitin, you'll not be able to play this. I think can you just play this? Is it possible?
Is there an audio embedded in this?
Yes, absolutely. Yes.
Okay, where is this? Because when I point the cursor,
Mhm.
I don't see anywhere.
Okay, what I'll try to do is I'll try to share my screen if it is possible, so that
Because I don't have that embedded in this
yeah.
the foil that I have.
Is the slide visible?
Yeah.
For the satellite CW. Is the audio heard? I'm sorry.
The audio heard.
Yes, it is audible.
Yeah. Was the this one visible? I'm sorry. I'm just.
Yeah, it was audible. It was visible. So, Varun, is this a specific plugin that
Yeah.
is being used along with the software SDR has?
Yeah, I just wanted to explain. I just wanted to explain that because of this one. Yeah. What I'm trying to do is I'm using an SDR Sharp is the software. I have connected a simple RTL SDR that is available in the market. This gets connected to a satellite tracking software that you can see on the right hand side, which is called as the G-Predict. So this G-Predict can be configured for the radios. It can be configured for SDRs. This can control your rotators. So what I have tried to do is I have tried to fix the Doppler effect, and then I have selected CW and here. And once the satellite pass happens, I will be able to receive. Here I have just shown the CW data. Anybody can receive SSTV signals, telemetry, any data, voice, everything can be received. So that is the total setup. Only thing that is required is some amount of the SDR Sharp doesn't come up with these plugins. There are some lookarounds, or you can put a mail to me. I'll share those the plugins that can be used directly for communicating between multiple softwares. The other thing that also be looked into is one of the things that has to be is you need to loop back the signal back. When I say loop back, the signal that is coming, or the radio signal that is coming from the satellite to the SDR, needs to be looped back into the sound card of the computer or the workstation that you are looking at. So there is something called as a VB cable. So that can be used for this loopback. So that's it. Nothing more in this one. So CW signal, you can look into the dits and darts. You can look into you can decode. By the way, the data that was sent, the CW signal that was sent is Merry Christmas 2025 from one of the satellites. So that was what we decoded at last year, meaning for the Christmas celebrations. So that was what we did. I think Nitin is not there, so I'll just.
Yeah, looks like he's disconnected. He'll connect again. In the meantime,
Yeah.
Varun, just a quick question from you to JO, particularly
Yeah.
around that telemetry. Is there a specific plugin available for SDR Sharp for telemetry?
SDR Sharp doesn't have a plugin per se, but there is something called as a telemetry sound modem that is available. So the telemetry sound is made by one UH7ZO, if I am right. Uniform Yeah, UH7ZO. 7H, UH7ZO. You can look into his website. So he will be, there are multiple sound modems that are available. This depends on satellite to satellite. You download one of this one, and then you can look into most of the information is available on the website, where you can just Google and say which is the telemetry baud rates. Depending on the baud rate and the modulation scheme, you need to select the sound modem. There is no plugin per se for that can directly do this telemetry decoding.
Varun, are you sharing? I think nothing is visible.
No, there was a question from one of the viewers. I was taking that question.
Okay.
Yeah, please go ahead. You can share the screen.
Okay.
Yeah. The next slide, Nitin. Yeah. Just showing for the telemetry decoding. This is from Lasar Sat. I have just shown. This is where there are messages that are sent. For example, I've shown one message: greetings from Leo, working on technologies for clearing up space debris. And I also told what would it show. It will give us the call sign. It will give us the the temperature in the y-axis, z-axis, because each of the cube sat would be experiencing different anomalies in space. So it will give you battery temperature. This is how it looks into. This is how it is shown. This is how it is decoded. Requires one thing is it requires constant monitoring. Second thing is RTL, SDR, or a rig can be used if you have a sound modem. In most of the cases, the newer satellites does it actually requires, which is having digital modulation scheme. The rig cannot be used. You need an RTL, SDR, and you need a sound modem. Sometimes this one you need a GNU radio, which is an application where you need to decode digital data and then get back. A computer with AirSpy would be the best preferred. Linux is the OS required. Windows works with some difficulty because I have seen people having difficulty with the plugin, especially the sound modem plugin that is there. They are having issues with the newest Windows 11 update. So that is one thing I'm just putting out. But yeah, it can be worked out. It can be worked out. Should not be a problem. This data can be directly decoded. So this is one of the applications that anybody can look into as an operator. So the next would be the SSTV, the last part of SSTV that I would rather speak about. The simplest way to get satellite images, multiple satellites. I have just given some satellites, but multiple satellites always put out SSTV as a part of it. So one of this was the last transmission from the Arctic sat. These are the 4 images as the last SSTV that was put out. In some cases, in case of IO86, LAPAN as well as QO100, transmission of SSTV is also possible. You can do both way transmission as well as reception. What are the apps used? RX SSTV, MM SSTV, QSSTV as on Linux as well as Windows platforms. There is a typo. I'm sorry. If it is on an Android mobile, you can use Robot 36, not 35. It is 36 on a mobile. I prefer Look for Sat app for the tracking part of the satellite. There are multiple other apps also available. That is, Kepler is one more app. Then there are there is an app by name Sterilium that can also be used. Simple Bofang UV5R for decoding is more than sufficient, or I can use an SDR. So I do have a video of an SSTV decoding here just to show how the SSTV decodes on an Robo 36 app. It might not play here, so I would rather go to the next slide where I have the the entire list of some of the decoded SSTV example. This is from the 32 series of the that was there, that was done from the International Space Station ISS. This have decoded using UV5R handheld radio with a Robo 36 app. I have, in some cases, they have also used an SDR with an RX SSTV app. So you get these kind of clear images. The only thing is you need to have a very good VSWR on your Yagi antenna. That is more than sufficient. The questions that I regularly get is, can I not use a rig, the antenna like a J-pole antenna for this? Or let us say I have a stationary antenna. You can get it, but the results will not be that great. Only if you have an overhead pass of an elevation greater than 70 degrees or 65 degrees, you will be able to get some good data. Otherwise, a Yagi would be the best preferred. So once you get into all these, QSOs, SSTV and other things, finally you end up with QSLs. I have just shown few that has been I have got, as well as I have given to somebody else for this one. So these are the QSLs that you can receive. These are the multiple satellites give out these QSLs. Even during when you try to help them out during their launch, during their stay, as well as when they re-enter, multiple QSLs are given. Meaning, I have also conducted where school children drawings have been transmitted as an SSTV from few Russian-based satellites. So I take drawings from school kids in or around my state in Karnataka. Then this has been through known contacts in the Rosmokos in Russia. I have been able to transmit those images over the view region. So this is also, somebody can take it up further. So ultimately, after this, I think I have nothing. If you have any questions.
Yeah, so just to add over here, Varun, especially on sending QSLs is a very good practice, just like how we do it on HF. There are many satellite operators who are chasing awards, just like how you have contests on HF. There are various awards that you can chase. So acknowledging the QSO, when you have a QSO via any satellite, it's very important. So either you send a physical QSL card, exchange a physical QSL card, or you can upload the contact in Logbook of the World, LOTW. So it's very important to maintain a two-way QSL, even on satellites as well. So before we go to the Q&A, I just want to again touch upon the FM satellites which we shared earlier, right? So a couple of FM satellites, and just want to touch upon the activity, what is happening in India. We just have a handful of radio hams who are active on the amateur radio satellites. So we want to see more activity. There are a lot of satellites available. It might not be convenient for everyone to work at a particular day or time. So definitely more satellites are available. If you look at our neighbors itself in Southeast Asia, the amount of activity is tremendous. All is required is a very simple setup. You don't have to go in for a rotator, azimuth elevation rotator, and all that. Even with two simple handies, you can build your own tape measure antenna, a handheld antenna, which was shown earlier. And with the necessary satellite tracking software and some amount of practice, you can have successful contacts via the satellites. And the thrill of working through the satellite is something totally different, because it is fast moving. You have a limited time. You have to exchange your report and also log your QSO. So it is very exciting. And at times it becomes more challenging, especially for the satellites which are at a very low elevation. For example, for India, if you look at how India is located, mainly towards Southeast Asia, and towards north you will find stations, but not towards the western part. So, but there are satellites which have got a bigger footprint. Like the RS-44, it has got a bigger footprint. You can work many stations more than 5,000-6,000 kilometers using these satellites, which are there on a higher footprint as well. And as you all know, we also have the QO-100 geostationary satellite, a payload on the geostationary satellite, which has got a very good footprint, and many stations are active on this particular satellite. So I encourage all of you to try, experiment. You might not be able to be successful in the first attempt, but definitely once you get used to operating through these satellites, you will find it very enjoyable. And also, we want more radio hams from India to come up on the amateur radio satellites. Okay, so I think Varun, you have covered everything. Devendra, we'll open it up for Q&A.
Yeah, thanks, Varun. That was really very comprehensive. You can stop sharing the screen. And just a quick one. While we discussed about having hello.
Yeah.
Yeah. So while we discussed about having a simple setup for working satellites for a college type of an environment, if they want to create a base station or have a separate setup, is there any recommended setup specifically for the colleges?
Yeah, I think they can start similarly like what I mentioned, Ajay, right? They can build handheld antennas. The only disadvantage is you have to be outdoor if you have to work to the satellite, holding the antenna, pointing it at the satellite, and it is basically outdoor activity. But if you want to do something from indoor, sitting at your radio station, then the college can think of building two Yagis. It need not be a cross Yagi. It can be a linear Yagi for VHF and UHF, and put it at a fixed elevation, say about 15-20 degrees, and have some way to rotate that antenna on the azimuth rotation. And they can sit inside their Radio Shack and have QSOs. So I would suggest first is to build a handheld Yagi antenna, go outdoor, have the tracking software on your phone or your PC, do a past prediction, understand when the satellite is going to be at your location, what is going to be the elevation, and try using that. And gradually anyone can upgrade to a fixed station kind of a setup where you will have Yagis externally, and you can work inside the comfort of your station.
Great. Thank you so much, Nitin. There's another question from VU39AJ, Alpha Juliet. Are there opportunities through AMSAT for collaboration with students or any specific engineering college for any mentorship or any other collaboration ventures?
Yeah, sure. If there is anything, please reach out to us. We recently approved a membership plan for students. We will announce that. We did not have it. So students can also become members of AMSAT India, and then they can participate in some of our projects. If the students have any project and if they want our guidance, definitely we can do that as well. And then for the satellite, for the frequency coordination with IARU, AMSAT India is also helping many of the satellite builders in the frequency coordination. And with respect to internship, yes, this we discussed in our last meeting, our internal meeting, and we definitely want to open up such opportunities as well.
Great. There's a question from VU2 Juliet Echo Foxtrot. I think this is specifically within your setup. How are you rotating your antennas at the azimuth?
So I'm using a azimuth elevation rotator. There are many makes and models that are available. So I'm using a Yaesu G5500. That is a azimuth elevation rotator, which has its own controller, and that controller is again connected to my PC, and the satellite tracking applications. They actually tell the rotator where to look for when a satellite is selected. And it actually rotates both azimuth and elevation to point at the satellite.
Great. There's a question around LoRa satellites. There are quite a few satellites which are using LoRa technology now. So is there any practical option for students, basically for PICO or FEMTO satellite projects? Do you see LoRa as a future technology in space communication?
Yeah, Varun, you want to take this?
Yeah. See, when you say LoRa, the single meaning, it depends on what is your payload. Essentially, if it is a scientific purposes, if the payload is only for scientific purposes, then LoRa is not the way around. But if it is for, let us say, I just want to have some sort of a network and I have to have some sort of a IoT kind of a system, then you can go for the what do you say, LoRa based system. The one more thing that I'm looking into is if you have, when I say a payload, when I say a technical payload, it essentially means you have a hyperspectral camera. If you have a camera or let us say a magnetosensor, which is you're looking into the magnetic aspects, these payloads require a higher bandwidth that LoRa module cannot provide. That is the first thing. And the second thing is, I don't think, kindly correct me, Nitin, if I am wrong. LoRa doesn't come under the requirements of an amateur satellite or the ham, essentially because the protocols are all closed.
Yes.
And in case of amateur ham kind of a satellite, it essentially, and he was talking about the frequency coordination work and other things. Essentially, the data that you are going to transmit should be open to public, where any ham or any person having a ground station to receive should be able to decode the data. So that is where it happens. Second thing, the thing is, he spoke about femtosat, picosat, and other things. It depends on how many months that you would like to have your satellite up in air. So if my scientific payload that is there, I require it for, let us say, 1 month, please go ahead, femtosat is fine. Because a femtosat will just do not have the capacity to be in space for a long time, and the battery capacity will be so small that it cannot stay for more than 15-20 days, because by the time the ISRO gives you the satellite in hand to operate, your 15 days is lost. So you have 15-20 days essentially to get data. So most of them go with the simplest is the 1U sat or the CubeSat, which is 1U, 10 centimeter by 10 centimeter by 10 centimeter. So I hope this answers the question.
Thanks, Varun. Varun, you are showing some 3D printed antenna. If you could talk about that a little bit.
Where exactly? I'm sorry.
No, the same slide, the last slide, Varun, on your foil. I'm just sharing that.
I just put a simple Yagi, a dual band Yagi, simply because if some of the interested people, if they want to build their own Yagi, they can use this dimensions to build their homebrew their Yagis. So that is the reason I just put those details.
Yeah, there are a lot of such designs available on the internet. Various designs are there. This is a simple, you can see it's a 3-element UHF, 3-element UHF.
And 2-element VHF.
2-element VHF, right? So this is good enough, as I mentioned, a handheld antenna, but only thing is that you'll have to be outdoor for this. Or you can also fix this antenna on your terrace at a fixed elevation and have some way to rotate this. So a lot of designs are available, right? From the 2 elements to 18 elements on UHF, 20 elements on UHF. A lot of designs are there, and there are applications available which will help you to calculate the dimensions of the antenna as well, right? There are modeling applications. A lot of things are available. Resources are available on the internet.
Great. Thanks, Nitin.
The pro tip is use a material which is light, because that was the mistake that I did initially.
Yeah.
use a material which is light, simply because at some point of time there is going to be a shoulder fatigue. I am 100% sure. If you are trying to do a hand hand tracking, there essentially, after, you might say the first day it would be great, second day would be great, by the third day you will have a sore shoulder. So make sure it is light.
Or you could even mount it on a camera tripod, right?
Yeah,
I think I have a photograph. You
yeah,
could
yeah.
mount it on a tripod, on a camera tripod, and that is much more easier for you to point it, right? You don't have to literally hold it in your hand.
Yeah,
The tripod will help you. All you need to do is change the azimuth and the elevation.
yeah, that's true. That's true.
Great. Nitin, in case if people need to get more information about AMSAT, what are the websites you'd recommend people can visit about satellite communication and AMSAT specifically in India as well as the international AMSAT?
Yeah, so for India, our website is amsatindia.org. It needs to be updated. But if you just Google search for AMSAT, it is amsat.org. That's AMSAT America, AMSAT UK. And a lot of, if you just Google for AMSAT, you will get all the links for the various AMSAT organizations as well. And if you are specifically looking for the International Space Station, it is aris.org, ariss.org. That is for the International Space Station. And there are a lot of discussion groups as well. The one is the SatNows, where you can discuss a lot about upcoming satellites, about your projects. The one thing that I want to highlight, if there are students over here planning to build satellites, if you are planning to use amateur radio frequencies, please make sure that you need to consider an amateur service on your satellite. Please think about this in the initial stage of the design itself, that you need to provide an amateur service on the satellite if you want to use amateur frequencies. So what is happening is many of the people, they come back to us, they have finalized the design, they're ready for launch, and then they come for the IARU frequency coordination, but they don't have an amateur service on the satellite. Right? So think about it. If you're thinking for any using the amateur frequencies, you have to think about offering an amateur service on the satellite. Let's see.
Yeah, just to add to what Nitin says, actually, to start with, I would rather recommend, being from an academia, I would rather recommend, actually, there are satellite payloads that are available on the web, where it can be procured, which is basically off the shelf. You can procure, start experimenting with it, where you have on a Raspberry Pi or something like that, you will be able to transmit, receive CW, you will be able to do SSB, you will be able to do FM, SSTV, digital data. This payloads are available. Any institution, if or any individual, if they want to buy, they can buy it, and then just the payload, and then they can do the experimentation and then get back to satellite building.
Varun, thank you so much. Varun, thanks a lot. Nitin, thank you so much. It was really a great, I think, session for all the group members and people who are there on the YouTube. And I'm sure it will remain as a good resource for anybody who wants to get into the hobby. So I'd like to thank both of you and AMSAT India, of course, for joining us today and sharing your experience. I'd also like to thank all the viewers, all the SWLs and hams who have been on the YouTube channel and asking questions. I'd also share that the Pune Hams Club, we meet every first Sunday of the month and at our club station. You can check our website at www.punehams.in. Can also, in case if you want to send your queries on email, you can send an email to pha at gmail.com. So that's our Gmail ID. Devendra, I hope that's correct.
VU to PHQ, sorry. It's a VU, Victor Uniform
PHQ,
2 Papa Hotel QS @gmail.com. And we are
sorry.
and we are available on all the social medias. So our handle is mostly @Pune Hams.
Thank you so much, Devendra. We also meet on all the weekends on VHF and UHF. VHF frequency is 145.100, and the UHF frequency will be 437.000. We meet at 10 p.m. IST, and it's there every weekend. So that's all from my side. And thank you so much, everybody, for joining. I'll say 7 threes, and I'll go QRT. Have a nice day. Bye.
Thank
Thanks,
you.
Thank you
Nitin.
very much.
Thank you.
73. Bye bye.
Bye.